When we look at ecology, one of the biggest things that people probably remember from middle school is food webs. A lot of students have seen food webs before, and this is just a way to show different feeding relationships. One of the things that you need to know is that energy flows in one direction. So when we look at ecology, the direction would be from the sun. The sun provides the initial amount of energy. That energy is going to the autotrophs, okay, your producers, because they're using the sun for their own food. Then from the producers, the energy flows to all the different heterotrophs. So the energy might flow from, let's say, a producer such as a grass, and that might flow to a deer, or the energy from the grass would flow to a cow or to a deer or whatever living things are eating that grass. But it starts with the sun, it goes to your producers, and then it goes to whatever different heterotrophs are feeding off of that as well. And that simple of a step is called a food chain. Food chain is just a series of steps where we are looking at where the energy is going, from what to what. So it's showing you the energy gained by one of the organisms, and then who is eating that organism is then gaining the energy from them. So a very simple food chain, might be that we start with algae. You always in a food chain start with a producer because they're getting their energy directly from the sun. And algae are eaten by the minnow. So the arrow is showing where the energy is flowing to. The energy is going to the minnow because the minnow is eating the algae. Now when you do that, some of the energy from the algae is lost. The algae use some of the energy from the sun for their own purpose, for their own use. Some of it also gets lost as heat within the living organism itself. Minnows also get eaten. Let's say that they get eaten by a bass, a little bit larger of a fish, and again some energy is lost. 90% of the energy is lost at every single step. Now the bass might also get eaten maybe by a larger bird like a heron. We could even substitute humans in there that eat bass. And again, at every step, heat is going to be lost. 90% of the energy in every single one of these, 90% is lost. Only 10% of the energy actually moves up to the next level. So by the time you get to the top of your food chain, or by the time you get to the top of a food web, when we look at those, you have little energy left available. This would be a simple food chain. We have our autotroph, our producer. In this case it's the flower, and caterpillars eat off of the leaves of flowers or the flowers themselves. And then you have a frog eating the caterpillar. So again, the arrow is pointing toward where the energy is flowing. Sometimes it seems a little backwards. Students are confused why the arrow is pointing to what is doing the eating, but it's really showing you the flow of energy. If a snake eats the frog, the snake is gaining the energy from the frog, and lastly an owl is eating the snake, so the energy from the snake is going to the owl. I already mentioned that only 10% of the available energy can actually move on to the next trophic level. Trophic level is just what we call each of those steps along that food chain path. So only 10% moves up to the next level. That means 90% at every level is lost. Could be lost as heat, it could be lost because the organism has already used some of the energy just to survive on their own. Now a food chain isn't very complex. At most maybe 4 or 5 parts in a food chain, but a food web is going to be much more complex. It is going to show you a lot of interactions because it's going to take multiple food chains and link them all together. So by the time you're done with drawing a food web, if you have really covered all of the interactions within that community, you might end up with something like this. You have arrows going some sideways, some are going in multiple directions, Many animals, you notice, have more than one arrow pointing to them, and that's because in this case the top of your food web consists of three large living organisms, all of which eat more than one type of living organism. So this wolf might eat the deer, it also might feed on the elk, it might also eat a skunk. So anytime you're looking at multiple connections, this wolf doesn't just eat one item, it could eat several different depending on what's available and easy hunting. You're going to have multiple arrows pointing to them. Notice at the bottom of your food web is where you have your producers. This is where your autotrophs are going to be, is at the bottom. So you're not going to have any arrows pointing to them. All of the arrows will lead away from them to maybe your smaller items first, like your herbivores that eat only grass or eat only berries or tree leaves, and then from there you're going to be getting into an omnivore. For instance, let's see if I can find one really quick. This bird is an herbivore because the only thing, I lied, it's an omnivore. Okay, we have it eating something from these leaves, so that would make it an herbivore. It's eating berries, so that's an herbivore, but it also is eating whatever that little bug is as well. So that would make this one an omnivore because it is eating plant and animal. But this mouse, for instance, is only eating grass. So this is definitely an herbivore. So you can tell a lot from a food web. They're very helpful. I mentioned trophic levels already. A trophic level is just every stop or every step within a food chain or a food web. You will always have producers on your first level. So producer or autotroph, whichever one you are calling that, same thing. And then your consumers are going to be on levels 2 through however many levels you end up having. Again, normally 4 to 5 before you kind of top out at one of your large predatory animals. So a consumer kind of depends on what level you are. If you're an herbivore, you may only be at level 2, but we also had that bird in the previous picture that would have been at level 2 in some cases, and in other cases it was at level 3. I'll show you some examples of that. If we go back to the example we had a minute ago with the algae and the minnow eating the algae. Okay, so because algae is at the very first step, this is the first trophic level, and they just go in order: second trophic level, third, fourth, so on. So this trophic level only has 4 steps. Again, 4, probably no more than 5 in most cases. The algae is also an autotroph, which is a producer. Those always are the first trophic level. You have to have something getting energy directly from the sun first. And then from there you are into your consumers. Because this is the second trophic level, it's the second stop, but it happens to be the first consumer we have in here because this is an autotroph. The minnow is the very first consumer, so it's the first consumer because it's eating plant life. It's an herbivore. Then you look at the bass fish. It is also a heterotroph, meaning that it gets its energy from the minnow that it's eating, but it is the second consumer. It's the second consumer within our list here, and it's a carnivore because it's eating meat. And then you have a heron, who's kind of at the top of this food chain, also a heterotroph. It's the third consumer in the list. So we have first level, second level, third, fourth, so on. But then we also kind of order our consumers. So the first consumer that's listed is a first order consumer, and then a second order, and then a third order. If it continued, a fifth order, fourth order, whatever. We would just put them in numerical order. Some of the other terminology that you're going to see, when you see something called a primary consumer, primary meaning first, so that's going to be your first level consumer. That's going to be the one that comes directly after your autotroph, like the minnow did. So that's going to be an herbivore. Your second level consumer is going to be the second consumer that's listed, and it kind of depends on what they're eating. Sometimes they may be eating plant life in some cases. Other times they might be eating a small herbivore. So they're we considered a carnivore in that case because they're eating meat. So omnivores or carnivores in this second level consumer. Your tertiary means 3. Your third level consumer would have been the heron in the example that we had on the previous slide. Normally at this point you're kind of at the top of the food chain. So these are going to be your larger carnivores. And then just a few pictures to kind of reiterate that. Plants are going to be again at the bottom. The arrow should always be pointing kind of away from the plant, so the herbivore energy is going to the herbivore from the plant. When a carnivore is eating the herbivore, the energy is flowing to the carnivore, so the arrow is pointing to what is doing the eating, because that's the particular organism that is getting the energy. And then all the way up to your second level consumer, and this one shows it just a little differently. So autotrophs are going to make up the base. They're always going to need to be in the largest supply, and then from autotrophs you can move up to your first level consumer, your second level consumer, and lastly your third level consumer, which kind of puts you again at the top of the food chain, in this case with an eagle. And we will be doing some practicing in class making a food web so that we can kind of analyze and look at what level different organisms are on. And so we'll be able to practice that in class. If you have any questions until that time though, please let me know and I'll gladly answer those. So that was a little bit about food webs and food chains.